Today we're going to talk a lot about linear functions, slope, and then we're also going to talk about 3D figures and volume. So first up, everything we've talked about with lines and functions. A function has one input going to only one output. Something is linear if it has a constant rate of change or makes a straight line. Domain is all your possible domain is all your possible x values, and range is all your possible y values. And then something's proportional if it's linear and has a starting point of 0. So first thing we're going to do is define slope. Slope is the same thing as rate of change, and we had a few definitions for it. Here they are. So slope is our change in y over change in x, which we sometimes write with a triangle. And then on a graph, that would be the vertical change over the horizontal change, or we could think of it as the rise over the run. But again, it's also the same thing as the rate of change. Next, we'll describe how we're going to find slope and y-intercept in each of the following representations. We'll start with slope for a graph. To find slope on a graph, we'll make a slope triangle between 2 points, and then we'll do our vertical change over our horizontal change as a fraction, so we'll have to count the squares there. Now for our y-intercept. For a graph, we find our y-intercept where the line crosses the y-axis, which is our vertical axis. We're going to move on to equations. I'll use a different color for that. I'll do it in red. Now, linear equations, we talked about them in the form of y equals mx plus b, where the number in front of x, or m, is my slope, and the number by itself, b, is my y-intercept, or my starting point. Then we'll do a table. So for a table, we find our slope by finding our patterns. And we find our pattern in y and our pattern in x, and we're going to write that as a fraction, our change in y over change in x. Our y-intercept has to be where x is equal to 0, because on the y-axis, x is always 0. Sometimes on a table we see where that is, other times we're going to have to figure it out for ourselves. First example, we're going to determine which patterns are linear or nonlinear, then we're going to determine our domain and range. So those bullet points we talked about at the top would help here. I know something is linear if it has a constant rate of change, or on a graph if it's a straight line. So we're going to see if our table has a constant rate of change. So I'm going to figure out my pattern. I know from 0 to 3 it's going plus 3, from 3 to 6 plus 3, and from 6 to 9 it's plus 3. We'll test the same thing on the bottom. From negative 5 to negative 10, it's going minus 5. Negative 10 to negative 15 is minus 5. And same thing over here. So it looks like we do have a constant pattern because every time x goes up by 3, y goes down by 5. So yes, it's linear. We'll write that. And now we'll do my domain and range. Domain is all of my x values. So let's write our x values, 0, 3, 6, and 9. Range is all of my y values, which would be negative 5, negative 10, negative 15, and negative 20. Remember when we do domain and range, if a number appears twice, we only need to list it once. Second table here, I want to know if it's linear or nonlinear. So I'm going to look at my pattern. From 0 to 2, it's plus 2. From 2 to 6, it's plus 4. Now this might not be an issue if I can just take my first fraction and multiply it and get the one after it. And then from 6 to 9, it's plus 3. Again, we don't know if it's an issue yet. Let's see what happens on the bottom. From 10 to 16, it's plus 6. 16 to 28, that is plus 12. And 28 to 37 is plus 9. Okay. Looking at these right now, it doesn't appear that we have a constant rate of change, but check this out. If I write these fractions out, so 6 divided by 3, what I mean to say is 6 divided by 2. 6 divided by 2 is 3. That would be looking at these two. Now, 12 divided by 4 is also 3. That's these two. And then 9 divided by 3 is also 3. So At first glance, you might think this is not linear because we have different numbers, but if you check and actually write your slopes out, they all turn out to be the same. So this is also linear. And so, since I know it's linear, I'm going to write my domain and range. So my domain is 0, 2, 6, and 9. My range is my y values, so 10, 16, 28, and 37. Now we're going to write linear equations for the tables. We need slope and y-intercept. So to find my slope, again, I had to find my change in y or a change in x. So let's find our pattern. We only need two numbers here, so I don't need to do the entire thing. I'll just start at the beginning. -2 to 0 would be +2. And then for my y's, 4 to 5 is +1. I don't need to go any further than that. I just need one change in x and one change in y. So let's write our slope. I'm going to call it m. M is equal to change in y, which is 1, over change in x, which is 2. So I have my slope. My slope is 1/2. Now we need our y-intercept, where we said before, that's where x is equal to 0. And I see that right here. So I'm going to write that my b, or my y-intercept, is 0, 5. Now we take that and put it in an equation. My slope goes next to my x, so this is going to be y equals 1/2 x, and my y-intercept is 5, so I do +5. That 5 should be by itself. Next table, again, we need to find our change in y over our change in x for our slope. So let's see, I only need two numbers. Let's take these first two. From 2 to 4 is +2, and from 14 to 8 is -6. I don't need to go any further than that. That's enough information for me. So let's find our slope, which is m. I do my change in y over change in x, so -6 over +2. I know that can be simplified. -6 divided by 2 is just -3. Or both of these numbers can be divided by 2. So you would get -3 over 1. That's the same thing. That's my slope. Now I need my y-intercept, which is where x is equal to 0. Now I don't see a 0 in this table right now, so I'm going to put a 0 where I think it fits. Well, my table is going up by 2, so the 0 would have to go on the left, right there. So I'm going to figure out what that would be. Well, from 0 to 2, it's +2. I'm going to figure out the pattern. Well, before, when I had +2 in my x, my y had to go down 6. So then I have to think to myself, what number, when I subtract 6, do I get 14? Well, that would be 20, because 20 minus 6 is 14. So this is my y-intercept. So I'll write my equation now. The slope goes in front of the x, -3x, and the y-intercept is by itself, +20. Next thing we're going to do is write linear equations from a graph. To find our slope, we're going to make a slope triangle between 2 points that hit the corner of a square. And then we're going to count our sides and write it as vertical change over horizontal change. So first up, I need 2 points that hit the corner of a square. I see some right here. Now I'm going to make a slope triangle out of those 2 points. Or in other words, just a right triangle. Now I should count my side lengths. The vertical side is 3 and the horizontal side is 2. So I write my slope as as vertical change over horizontal change. So in this case, my slope is going to be 3 over 2. I look at my line. This is a puff, puff, positive line, so this should be a positive slope. So I'm good. Next thing we need to do is find our y-intercept, so where the line crosses the y-axis. This line crosses right there. That's the point 0, 2. So that's my y-intercept. Now I'm going to take those two things and write the equation. My equation should be 3/2 x plus 2. Next line, let's start by finding our slope. I need 2 points to hit the corner of a square. How about this one and this one? Now we'll make our slope triangle out of that, so a right triangle out of the 2 points. Now we need to count our side lengths. I know that each side is 1, so if I do my slope, that would be vertical change over horizontal change, or 1 over 1. That's a little redundant, so I should probably just say 1. But if you look at this line, it is nice negative, and so we need to put a negative sign with our slope, because slope due to be going down the mountain from left to right. So my slope is -1. Now we need our y-intercept. My line crosses the y-axis right here. That's the point 0, -1. So let's go ahead and write our equation. Our equation should be -1 goes in front of x, and then my y-intercept is by itself, so -1x minus 1. Last thing on this page is functions. Something's a function if, as we talked about before, one input goes to one output. Look at this first table. I see a problem. There appears to be 2 zeros, but do you see how they both go to 1? They're going to the same output, and so that's okay. We've just repeated ourselves here, so that doesn't change anything, so that's okay. Looking at my other inputs, each of them only has one output, so yes, this is a function. If we look at the mapping below, we're going to again check that one input goes to one output, while -1 only goes to 2. That's good. 0 only goes to 2. That's fine. They can both go the same place, just like I can send 2 students to the nurse at once. -1 and 0 can both go to 2. That's fine. They just can't go 2 places at once. 1 goes to -3, and that's it. Good. 2 goes to -2. That's it. And 8 goes to 3, and that's it. So yes, this is a function, even though we have -1 and 0 both going to 2, it's still a function because those numbers still only have one output. Moving on to slope between 2 points, my slope formula is change in y over change in x, which is just y2 minus y1 over x2 minus x1. For this problem, I'm going to start by writing that formula, and then I will number my point. And now we just have to plug into our equation. Well, y2 is my y value from the second point, so that would be 6. y1 is my y value from the first point, so 4. x2 is my x value from the second point, so -2. And x1 is my x value from the first point, so 0. And I subtract that. Notice it has subtraction. Make sure you do that. So 6 minus 4 is 2, and -2 minus 0 is -2. I can simplify that fraction. 2 divided by -2 is just -1. So my slope is -1. Another quick note about slopes. If I have a number over 0, that's undefined. And if I have 0 divided by a number, that's 0. Done with slope, now we'll move on to volume. You have your 3 volume formulas there that you're going to need: cylinder, cone, and sphere. We're going to find the volume of the cone below, so I need to use this middle formula. I'll write that down first. Looking at my cone, my radius is 2.5, which is the middle of the circle to the outside, so half the circle. So here's my radius. My height is obviously the height of the cone. Now we're going to plug in those numbers in our formula. So 2.5 goes in for R and 11.5 goes in for H. Make sure when you write it down that you square your radius. What you can do next is just plug this all into your calculator. Make sure when you are putting in a fraction, you close the parentheses around it. So 1/3 should be 1 divided by 3 in parentheses if you put it in your calculator like that. When I put this in my calculator, I get about 75.3, and this was in centimeters, so I'll write that, but it's volume, so it should be cubed. Last thing, what's the relationship between the formula for the volume of a cone and the formula for the volume of a cylinder? Well, you see that 1/3 in front of the volume of a cone, which means that it's 1/3 of something. Right after it, it's followed by the volume of a cylinder. So we talked about how 3 cones of the same radius and the same height fit inside of a cylinder, which is why we see the 1/3 in our equation. So our relationship is this. A cone is 1/3 of the volume of a cylinder, or in other words, 3 cones go into 1 cylinder.